All right, so it probably comes as no surprise to you that we can't really do a unit on the hydrosphere or water on Earth without talking about the oceans, right? Like, that shouldn't catch you by surprise, right? Because so much of the water on Earth is stored in our oceans, we probably got to talk about oceans. So, and that's actually a large part of our unit. So if you're into oceans, you're going to learn a whole ton about them now. So one of the questions that I always wondered when I was your age is, why in the heck are the oceans salty? In fact, I can remember the first time that I traveled to the ocean. I had moved to North Carolina from Buffalo, New York, never been to the ocean before then. And when I got here, I went to play in the oceans and got a mouthful of seawater. And you guys know, if you've been to the ocean, that a mouthful of seawater is no fun because of how incredibly salty it is. Well, what I wondered was, where does that salt all come from? Like, it's got to come from somewhere, right? Well, the answer to where does the salt in the ocean come from is actually pretty interesting. You should remember from our properties of water video above, right, in your notes, it's up there somewhere, that water is the universal solvent. It's really good at dissolving things. And so what happens is fresh water on Earth will dissolve chemicals that are inside the Earth's crust, and it will wash those chemicals into the ocean. How cool is that, right? So one of the reasons why the ocean is salty is because it's filled with dissolved chemicals. Now, why are there dissolved chemicals in the ocean? Well, water's the universal solvent, so wherever it happens to be, its polarity is pulling at other molecules. We said in the very first video of your notes that water on Earth is rarely pure, right? That's because it's so good at dissolving stuff. Well, that's what you see happening here. Water is actually dissolving chemicals that are in the Earth's crust, and it's eroding those chemicals and then washing them into the sea, causing the ocean to be as salty as it is. I thought that was awesome. Now, there are some other reasons why the oceans are salty, and you can see that in bullet 2. Sometimes you've got ejections from volcanoes that can end up in the oceans, and that adds chemicals, making it salty. Sometimes there are some suspended particles that are pulled into the oceans by winds. But easily the most important reason why the oceans are salty is because water is constantly dissolving chemicals into the crust and eroding them into the oceans. That's cool. Now, you gotta know about the salinity of the ocean, that it's not even everywhere you go. There's not like a universal amount of saltiness from one side of the ocean to the other. And there's two main factors that affect the salinity of the ocean. Salinity means saltiness. One of them is evaporation. If there's high rates of evaporation, or if there's lots of ice freezing in any particular area, that's going to take some of the salt, or it will increase the amount of salt that's in the water. Okay, so if water evaporates, the salt's left behind, now you've got more salt trapped in the water. If water freezes, the salt's left behind, now you've got an increased salt content in the water. That's worth knowing. Now, there are places on Earth where you have a decreased salt content, and a really good example is at the mouth of a large river. You know, and if you think about it, it's because at the mouth of a large river, you got lots of fresh water that's going into the oceans, and that fresh water doesn't have salt in it yet. And so when that fresh water enters the ocean at the mouth of a river, you end up with more fresh water, less salt water. We tend to call that brackish, and it's a lower salt content than you would find out in the middle of the ocean. Okay, so just understand that salt isn't universal from one side of the ocean to the other. Natural effects can change the amount of saltiness of the ocean water that you're dealing with. Now, there's one more source of chemicals inside of ocean water. And that one last source is something we didn't discover until like the 1950s, which I think is awesome. And you might remember this from when we were in 6th grade. There are hydrothermal vents down at the bottom of the ocean floor. That's places where hot water and chemicals are seeping into the ocean all at one time because there's cracks in the Earth's crust. There are these weak spots in the crust where magma rises, super hot magma rises, and that superheats the ocean floor. Well, in those places where there's hydrothermal vents, you've got water that will seep into the vent, into the cracks on the floor. And when it gets there, it's superheated, right? Because it's an incredibly hot area. I think you might know that ocean floors or super hot places dissolve better than super cold places do. So as that ocean water seeps into the hydrothermal vent, the superheated hydrothermal vent, you get even more dissolving than you would have otherwise gotten. And that brings more dissolved minerals back into the ocean. So hydrothermal vents, because they facilitate more dissolving, because they're super hot and water is seeping into the vent, oftentimes put more minerals into the ocean than otherwise would be there, causing the oceans to feel salty to us. By the way, the third bullet is actually incredibly cool. Scientists think there's enough water seeping into those hydrothermal vents that every 10 million years, all of the water in the ocean will seep into a vent and then come back out again. I mean, that's just an amazing amount of water churn through hydrothermal vents. 10 million years might feel like a lot, but think back to our geologic time unit. The Earth's been around for 4.6 billion years. So in that entire period of time, the entire contents of the ocean have gone and burbled through hydrothermal vents and back out again multiple times. It's incredibly cool. And the last part of this section of our notes is something that shouldn't surprise you if you paid attention when we were talking about water properties earlier. Oceans actually play a really strong role in regulating our climate. Here's why. Oceans hold on to lots of heat. That was specific heat, the property of water from earlier in your notes. They hold on to lots of heat. By the way, they also hold on to lots of carbon dioxide too, which is true. But in this particular case, I'm interested in the fact that they hold on to lots of heat. And the reason that's so important to us is because it helps to have seasons or push seasons later than they otherwise would be. Here's your proof of that. If you ever watch the weather here in North Carolina, you'll notice that in the wintertime, it's warmer down at the beach, down near Wilmington, than it is here in Raleigh. Well, why is it always warmer in Wilmington than it is in Raleigh in the wintertime? Well, the reason is because that giant ocean that sits off the coast of Wilmington is holding on to heat, and it's releasing it slowly into the atmosphere. So that released heat that's close to Wilmington is keeping Wilmington warmer than it otherwise would be. By the way, the reverse is true in the summertime. If you ever look at the weather, it's warmer in Raleigh than it is at the beach. And one of the reasons for that is over the course of the long winter, the oceans really do cool down. That's why the water is so cold when you go down to the ocean in March and so warm when you go in November. It takes some time for the ocean water to cool down. And once that ocean water finally cools down in the springtime, that's when summer begins. So now you got this big, huge pot or bathtub, for lack of a better word, of cold water sitting off the coast of Wilmington. And so that releases that cool air up into the atmosphere, and it keeps Wilmington colder in the summer than Raleigh would be, which I think is really, really neat. So the oceans help to regulate our temperature. Now, why should we care about all of that? Well, we should care about that because with the oceans releasing heat during the winter and keeping us cool during the summer, what we don't see is mad, crazy fluctuations of temperature from day to day here on Earth. And that is super ridiculously, fantastically important. If we had really big swings in temperature where we went from very hot to very cold, sustaining life would be hard to do. When you were in sixth grade and we studied what makes a planet habitable, one of the things was an atmosphere that can kind of act like a blanket and keep you from being too warm or too cold at any given time. Well, an important part of our atmosphere's blanket is the oceans because they're holding on to heat and releasing it, keeping our temperature sort of even and stable no matter what's happening everywhere else. Why does that all work? Well, it goes back to properties of water again. It goes back to that idea that water has specific heat as a property. It takes a lot to change the temperature, to increase the temperature of water. It takes a lot of energy to cool water down too. So that's kind of a really important role that oceans play in sustaining life here on Earth.